All right, hi everyone, it's Johnny again from the Polaris team. I'm back at it at NeurIPS walking through the poster sessions. And I was walking through the sessions and I saw a really interesting paper talking about defining the gold standard in small molecule drug discovery benchmarking. This is obviously super relevant to a lot of the work that we're interested in at Polaris in terms of better standards and guidelines around dataset curation and benchmarking in the space. So before we dive into the paper, do you want to quickly introduce yourself and your
Yeah,
background?
of course. My name is Ha, and I'm a member of the Melo Lab in Vanderbilt University.
Awesome. So can you describe a little bit some of your experience and the challenges you've seen around data sets and benchmarking in the small molecule space specifically?
Yeah, of course. Like for me personally, when I do this kind of work, I often feel like I have to navigate through a very large database and selecting different data set, reading technology of the data, and also to how to clean the data is very challenging as well. And especially that I'm not like from chemistry background, so when I look into this data set, it's just like random symbol for me. So that is like the motivation where like how to clean the data, how to
Right.
select data set and stuff like that.
Right. Okay, cool. And maybe do you want to start by just talking to us a little bit more about sort of the work that went behind sort of the curation pipeline that you've built? What sort of things are you filtering for? And then some of the data sets that you ended up presenting today at the poster?
Oh yeah, of course. So our project, we curated 9 different data sets from belong to different drug class and also different protein class. So these are from PubChem, and we selecting data sets from the primary screen to confirmatory screen and then counter screen to make sure the low false positive rate and also like the specificity of the molecules. And we make sure that these data sets they are from the same organization or the same project or the same species. And after collecting this data set, we read into the technology of the data set and the flow between different assays, like the follow-up assay and which one comes first and stuff like that, so that our combination will make sense. And and after that, we filter them through like a wide array of filters, from like duplicate removals to inorganic substance filter, and then interference compound filter, and so on. So our data set, at the end, we output SMI and INCHI, and also different formats such as 2D graph and 3D graph. They are all ready to use, and they are all open source, including the filter and the curation code. So we are hoping that like this curation pipeline can help future computational chemists when they look into this data set. They can know like what step need to be taken to clean the data and preprocess the data before you put the data into the model. So yeah, that is
Amazing.
like
Yeah. And what are some of the data sets that people can already use today? I see here you've grouped certain data sets around target class. Can you
yeah.
tell me a little bit more about
Yeah,
that?
so we have 5 different target class from GPCR, and like GPCR, they account for like around 40% of new drugs. So it's very important drug class. And among these PRs, we have the orexin-1 receptor, M1 muscarinic receptor. We also have different ion channels, and we have transporter and kinase and enzyme. And actually, our paper also like detail what are these like protein, why are these protein important in drug discovery, such as they can be relevant to some neurodegenerative disease, or they can be for some kidney disease and so on. So
Amazing.
yeah.
Cool. Awesome. Thank you so much. Cool. So that was a great overview of the data set section of the poster. Now the other half is talking about benchmarking. And so I'm here with Shin, who do you want to start by quickly introducing yourself?
Yeah, hi everyone. I'm Shays from Vanderbilt University and currently working under the Network and Data Science Lab and the Mailers Lab.
Cool. So tell me a little bit more about sort of the work you're doing around proposing different splits and the benchmarking aspect of the work here.
Yeah, sure. So first of all, we want to benchmark lots of models, and we want to have a really robust evaluation frameworks. So we basically introduce 2 splits methodology. One is random and scaffolds. Each of them have 5 splits for each data set, so that our models can be fine-tuned on each split, and we can average the final results to see if our models is robust under the data sets and all the generalization problems.
Amazing. And where can people find the benchmarks that you've proposed here? Is it all in the paper and links?
Yeah, it's
to the
on the
code?
papers. You can visit our websites and click to the source code or
Amazing.
something. Yeah.
How do you hope the community will use the benchmarks and the splits you proposed here to sort of accelerate the work that's being done in small molecule drug discovery?
Yeah, definitely. So first of all, our data set has a really high quality labelings. So it will be nice if people develop new methodologies that can perform well on our data sets. But I want to note that our data sets also has a really intricate data issues such as the class imbalance and also the distribution shift caused by the scaffold split. So it will be nice for the computer scientists focus more on the data sets and develop data-driven artificial intelligence tools that can perform well on the data.
Amazing. Thank you so much for the overview. You'll be able to find a link to the paper down in the description below, and hopefully very soon these data sets on Polaris. Thanks.